let's do an RSA pen and paper exercise. Why RSA is important? RSA is the foundation of today's cryptography. If we are sending something over SSL, SSH, you are using a way of public key encryption, which is what this is about. And as SREs and DevOps engineers, it's really important, or as software engineers in general, it's really important to understand how this type of encryption works, how to create keys, how to convert them into something else, how to store them as key stores and trust stores, and that type of things. So let's start. The first thing that RSA is going to do is it's going to create two numbers, two prime numbers. We have to choose two. They have to be really big, but for the sake of this video, to make it easier to understand, I will pick two really small ones, like 3 and 11. Then we are going to multiply them together. So 3 times 11 becomes 33. Then, using the Euler's phi function, we are going to use it right here, is p minus 1 times q minus 1, just like that. So m becomes, well, this is 2 times 10, it becomes 20. Now we need to find a prime number that is a coprime to 20. That means it cannot divide it. We could use 5. No, because 5 divides it. Then we have 7. 7 cannot divide it, so 7 is good. Let's put it right here. And here, we extract the first piece of information that is critical. N equals to 33 and E equals to 7 is the public key. Okay? Now this sounds familiar. Now we're going to continue. All our math is not done yet, so we can generate our private key. The private key says that we have to multiply E by D, and it must be equals to 1 modulo M. Okay, we have E, so it's basically 7 times D. This is the one that we have to find out. Divided by 20 is equals to a number with a remainder of 1. I will save the math, but basically, in this case, if you do 7 times 3, and this is why I picked the small numbers to make it way easier, divided by 20, this is 21 divided by 20 is equals to some number, 1.05. Now this doesn't have the modulo 20 is going to work here. Let's see. If you do 21 divided by 20, just to confirm, yeah, it's 1.05. Let's remove the 1 because we need only the remainder part of it. And let's multiply that by 20. That's 1. Okay, so in this case, we can confirm that D is 3. Now, this is the second part of information. We still keep N, which is 33, and D, that is 3. This is the private key. So now we have public key, we have private key. Why is called D? Because it's called, I called it like that because it's decryption, and E is encryption. Let's say the client is going to encrypt with this, and we're going to decrypt with this one. Okay, perfect. Now let's go to this side. Let's say that the client is here. You have a client that is going to send you some information, and you have to decrypt it. The client decided that it's going to send you a message that actually has only one value. It has 4. They wanted to send you the number 4, but it needs to be encrypted. So you have to generate a ciphertext. The ciphertext says that you have to take your message to the power of your E modulo N. Okay, and we have everything to do this. So let's bring it back here. So we have 4 to the power of E, which is 7. This is the result. This is the number. Modulo N. So you have to divide this by 33, subtract the product for 496, and multiply it by 33, 16. Okay, so your ciphertext at this point is 16. This is what you are going to send over the network or whatever. This is what you are going to have to share with the server so the server can decrypt it. So how is the server going to decrypt that? Let's put it right here. The server will say, okay, I have a ciphertext of 16. I have to find the message, which is the ciphertext, to the power of my decryption key or my decryption value, modulo N, right? Because it's the private key. So let's do it. Our ciphertext is 16 to the power of 3, right? Because that's the one that we're going to use for decryption. This is 4096 modulo 33. So let's divide it by 33. Let's subtract 124. And let's multiply by 33 again. 4. And this is the end-to-end from the generation of the public and private key all the way to sending a clear text or choosing a clear text value, encrypting it, and decrypting it in the server. So I hope this is useful, and leave a comment if you like this, if you have used anything like this, if you have had troubles with RSA in the past, managing key stores, anything that you would like to share with us. Thank you so much.